Christmas lights. Christmas toys. I've made a few changes to the H bridge. As you can see, there is 4 9-volt batteries, which is very odd, something I've never tried before, but it is traditional for a Newman motor. Previously, the motor coil, which is currently running on 100 volts and a couple of milliamps. Positive comes in, top 2 transistors, bottom 2 transistors. As we all know, a H bridge goes like that, every pulse. But the difference is, on this occasion, I've managed to get a lot more power out of it because I'm running, instead of using collector current to trigger the bases, I'm using current from these 9-volt batteries to trigger the bases. So instead of the collector from the motor going to the main driving transistor and then through a resistor to the second driving transistor and then back through the base and then obviously through the third one and the opto isolator as well. Yeah, I've gone all out here. So 3 transistors to boost the signal and an opto isolator. But in this occasion, the 9-volt battery is instead going straight to the second transistor, the second biggest on the Darlington pair, and then via a resistor to the third, and then straight up through that same resistor to the opto. And this has managed to get my top voltage. I've done this, of course, because when this motor spins, if I put 200 volts in it, I'm actually getting, because of the rotating magnet inside, which is freaking huge, that 200 volts I'm putting in isn't a problem for these transistors, but at the same time, as you can see, we've got somewhat of a square, and on top of that square we've got another big bump, and that adds an extra 100 volts to it. And that's providing considerable difficulties. So I managed to skirt that issue and basically double the voltage I can run through this thing without it damaging it. Just over double, actually, oddly enough. So, and this is the first time I've tried it. I've only tried this with 1 channel before, not a H. But what are you going to do? Let's live large and turn it up untested. Okay, cracking up nicely. Pretty good. So this is currently at 300. And I should put another current meter on it. Obviously I've got quite a few, I just didn't bother on this occasion. About 5 milliamps at 300 volts. And at this point I'm going to disconnect my scope so it doesn't blow sky high. I think that would be quite wise at this point. Actually, you know what I'm going to do? I'm going to turn the voltage down so I can actually touch the clamp, then disconnect my scope. At the moment it's actually pretty much only running on this capacitor. The motor runs for ages. It takes quite a long time to slow down between that capacitor and the flywheel. But now that it's down to 200 volts, I can probably take this off fairly safely. The reverse EMF spikes coming from this coil were huge, i.e. 200 volts in was giving reverse spikes of about 6,000 volts. So yeah, that's very bad for scopes. Okay, back up to 300. Let's just juice it right up and see what happens. It's a magnet. It's anomaly there. When I was running relays earlier, one of the relays failed in the middle of the operation, and it basically reversed the field at the wrong time. So naturally that flywheel had something to say about it, and the silicon coupling for the magnets trying to reverse all that weight all at once. Thankfully it didn't explode, but it basically did, nearly did. it didn't destroy the coil, which was great. That would have been a real shame. So, about 520 volts, give or take 10 milliamps, it's about 5 watts. That's quite good. I don't think much of this generator. It's a bit crude and takes, well, quite a bit of energy to turn, so it's a bit wasteful. But the voltage is also too low. I didn't have much luck with these automotive globes. They would only glow half as bright as they should. But yeah, I'm still playing around with loads. But this is now what the load will be. A modified alternator. Basically, I can spin it by hand and produce just over 20 volts. So, that's where we're at. Looking pretty good, huh? And this 3D printer sitting here gratuitously, what I'm about to do is print off another housing for the coil, so I can customize the wire size a little better. What I would like to do is try with more wire and with less. I suspect if I try with less, the reverse EMF I was seeing on the scope would correct itself a little, and it would get back to sort of generating about its own nominal voltage rather than above. Could well be wasteful. This is sounding quite bad right now. I've got to turn this down before I start having difficulties. In fact, how about I just turn it off? There, down to 500 volts. Obviously the power for the triggering circuit has been garnished from this power supply, and the base trigger has been garnished from the 9-volt battery, so it's not completely off. But this capacitor, which is not huge, is draining very, very slowly. So, pretty happy all in all. I'll show you how we go when we make some more progress. Merry Christmas.